Thank you all for joining us today. We're really excited to see so many of you able to join. Today, we're going to have Doug talk about the LI-6800 Porometer Fluorometer and some of the new features that we now have implemented, including leaf angle, GPS, and the barcode generator. Like I mentioned, Doug Lynch, he's a senior scientist here at LI-COR, and he'll be the presenter today. My name's Abby Brooke. I'm a product manager here. And I'm going to help moderate and direct questions throughout. And then also joining us, we've got a team of panelists. These guys are going to be able to take your questions throughout today's presentation. And then at the end, we're planning on doing some live Q&A. So we've got Jason Hupp, who is a principal scientist, Juan Jose Micheli, who is the international sales manager, and also Eric Price, who is a technical support scientist. So throughout today's presentation, if you have any questions, go ahead and send them to us through the Q&A tool on Zoom. Like I said, we will chat you throughout and type you answers back, but then at the end, we will maybe discuss some of those questions in more detail at the end and also take any additional questions you have. So with that, we're going to go ahead and get started with Doug's presentation. So just need just a second and I will get that pulled up.
Hello, thank you for joining us today. My name is Doug Lynch, and today I will be sharing with you some updates to the LI-600. So we've added some hardware components that allow for both location information through a GPS transceiver and some hardware to allow leaf angle calculations. And we also have some software updates to discuss. So just a quick outline here, we're going to be talking about the hardware updates first. As I said, these include the incorporation of a GPS transceiver and also an accelerometer magnetometer, which can be used to get information on the angle of the leaf, or at least the angle of the instrument during the measurement. And then we'll, at the end, go over a couple of software updates in version 2.0.0 that include improved workflow for quicker measurements, or at least time between measurements, and some updates to the software to allow you to generate your own barcodes automatically. So let's first talk about these hardware updates and what that includes. So first, there's a GPS that provides you with information on where the measurement is made on the globe, as well as local time. That's all obtained from communication with the GPS satellite network. And this gives you the ability to sync your clock with actual GPS time, as well as giving you the location information. And you'll see a GPS icon in your status bar at the top of the instrument to indicate when you have enough satellites to get a good location fix, as well as a new variable group in the data file associated with that GPS information. And that includes these variables down here at the bottom. So you'll see you have your time and date with GPS, your location, including latitude, longitude, and altitude, as well as some kind of quality info on your fix, the number of satellites currently being received, and this horizontal dilution of precision, which gives you an idea of how good that GPS fix is. The testing we've done to date indicates this GPS works pretty well, even in fairly dense canopies. This example data set here was taken in a forested area near our location here in Lincoln, with no problems even underneath the canopy in midsummer. So that's the info added to the device from GPS. And where it gets really useful is to combine that data with the outputs from this second device called an accelerometer magnetometer. And what this device provides is 3 measured parameters that we're referring to in our data sets as pitch, roll, and heading. And so the 3 parameters here give you an idea of sort of the rotation on 3 different axes of the instrument. So pitch describes the rotation forwards and backwards. So if I was looking, if I had the instrument pointed this way, it would be forwards and backwards along that axis. The roll is the rotation, the opposite axis there. And then finally, the heading output gives you the rotation along this axis. So you could consider that your cardinal direction. And with these 3 pieces of information, we can calculate sort of the plane of the leaf during that measurement, which hopefully is maintained from the start of the measurement, and gives you useful information to put the stomatal conductance and chlorophyll fluorescence measurements into context. Now this adds another variable group to the data set that we're calling leaf angle. And it starts with those 3 parameters that are directly measured. And these other parameters are calculated. And those calculations are not performed in the embedded software on the instrument itself, but instead they happen when you download the data to your PC. That the application residing on your PC or Mac is what does those calculations. And so these won't be available directly on the instrument, but they will be in your data set when you download it, because these are combined with the GPS information. So let's kind of walk through what these different variables here are. There's essentially 3 steps required to get all of those calculations. The first step is to use those 3 parameters I just described, pitch, roll, and heading, to get information on the leaf. This is a nice figure and a nice paper actually that describes a lot of these calculations. Is this reference here from 2014. And essentially the pitch, roll, and heading give us information on how that leaf, the plane of that leaf, is oriented. And the 2 parameters that we calculate and need are a slope. So we call that the slope of the leaf. And so that's the sort of inclination. So horizontal would be no slope. And so the inclination from horizontal. And then secondly, the azimuth of the leaf, which is the rotation from north or south, or whatever orientation you wish. But in this case, it's the orientation from north. And so those 2 parameters sort of describe the plane of the leaf in space. Second, we need to understand the position of the sun. And this comes from our GPS location information, where we know where we are on the globe. And with that and the precise time, both diurnally and within the year, allow us to calculate where the sun is in the sky. And we need similar parameters for the sun. We need to know its azimuth, or rotation east and west. And we need to know the zenith angle. So how far from vertical is the sun? There's a lot of literature on these calculations. This particular image is kind of a nice demonstration of this that comes from a paper describing solar panel absorptance of light. But regardless, in our case, you can think of this as our leaf plane, and we wanted to understand the angle of that plane with respect to where the sun is at that current time. So now that we know the position of our leaf and the position of our sun, or light source, we can calculate some useful and relevant physiological parameters. And we're giving by default 2 calculations. One is the angle of incidence of the leaf, here shown as alpha. And basically what that describes is the angle of the leaf plane with respect to the sun, the difference from normal, or the difference from 90 degrees. So that's that alpha, or angle of incidence. And this is how it's written as the variable name in the data set. And we also give you what we're calling direct percent, which is the cosine of that angle times 100. And that just simply tells you that if the leaf were completely normal to the sun, that would be 100% of the possible direct irradiance. But because of that angle, this gives you what percentage of the light this leaf can, or is incident on this leaf because of the angle. So it's following the cosine law of light interception. And it just tells you sort of how much light is not being intercepted because of simply that angle of incidence. So I'm going to show some examples of measurements here. And I just have one quick slide on, why did we do this? Why do we think this is important? And there's a lot of literature on the importance of leaf angle, both from a sort of singular leaf and a canopy perspective. And I'm just going to show one example here. I think this is a nice example from Falster and Westaby back in 2003. And what they show is what proportion of leaves from two different species, I think in this case, are receiving light within, receiving light that's low. So low on the x-axis here is incident light intensity. And what percentage of the leaves when the mean angle is 27 degrees, so a shallow angle, versus a different species where the leaf angle, or at least the mean leaf angle, is much different at 74 degrees. And in the morning, when the sun is kind of barely up over the horizon, you can see there's quite a bit of variation in leaves and what kind of light those leaves are receiving. But the two species are not drastically different. But here at midday, when the sun is up in the sky, the leaves that are more shallow, this black bar, there's a lot of them receiving way more light intensity, whereas that species that has a much sort of steeper angle, none of those leaves are receiving much of that higher irradiance. And so leaf angle is a really important property to describe light interception on a particular leaf surface. And in this case, they're showing this kind of final graph here is light response curves of CO2 uptake for different theoretical species, shade species versus full sun species, and how that might play a role in, if you have a model of your population and you have light response curves, you can kind of get an idea of total carbon uptake for this population. Now, of course, the LI-600 does not measure CO2 uptake, so this type of light response curve would need to be performed with a full photosynthesis system, such as the LI-6800. But this is a nice example showing that information on leaf angle can really help you scale up your measurements. And I'm going to show you some example data sets using the LI-600 that also show some valuable information on how leaf angle can help you with your measurements. So first, I'm going to show just a really brief experiment that can be done with this instrument quite easily. Potentially, in this case, I used an artificial light source, so just an LED light source, and I have my leaf acclimate normal to that light source directly beneath it. And I make a measurement of stomatal conductance here on the right, value of about 0.2 moles per meter squared per second, as well as 5 PS2. And this happens to be, I set it up to be at very high intensity light for a pretty low value of 5 PS2 of around 0.2. And then in this experiment, all I did was staying clamped on a leaf, just sort of rotated my instrument. And in this case, I was rotating just the roll of the instrument. So that's why I'm plotting it as a function of roll. But if the instrument were varying in multiple directions, then you would need to combine pitch and roll and heading to get an angle of incidence. But here the roll is kind of directly my angle of incidence. So when I go to a slightly different angle from normal, I'm going to reduce the incident light on my leaf. And you can see here, when I do so in either direction, 5PS2 very quickly rises. And here I'm only waiting 15 or 20 seconds between each of these data points. This is a pretty rapid experiment. And you can see how quickly 5PS2 is impacted by incident light intensity. So the further away I go from normal, the lower the light intensity that's incident on the leaf is, and higher 5PS2 values result from that. And again, this is only done over a few seconds at each of these measurements. And so that leaf angle can give you quite a bit of good information on explaining what your 5PS2 is. Now, in contrast, over the time scale of these measurements, stomatal conductance is not being impacted. So there's very little to no to little change in stomatal conductance over the 4 or 5 minutes that this experiment took. And so stomatal conductance, which responds to light intensity much more slowly, wouldn't be impacted by this type of experiment. So one more example data set. This is a larger data set, involved diurnal measurements, so measurements over the course of a single day, and this was done on some cherry trees. And it was about 70 leaves that were measured repeatedly with about an hour-and-a-half time interval between each measurement set. So every hour-and-a-half, we would go out and make measurements on about 70 leaves on a couple of different trees, and then take a break and go measure those same leaves repeatedly throughout the day. And this was done on a day in approximately midsummer. And here in these plots, I've just bucketed the data fairly arbitrarily into eastward facing leaves, which are in blue, and westward facing leaves, which are in red. And kind of as expected, my angle of incidence over the course of the day. So both east and westward facing leaves have a high angle of incidence very early in the morning. Now, as the sun starts to come up, those eastward facing leaves are facing the sun almost directly early in the morning. This 10 to 11:30 time frame is when the sun is still fairly low in the sky, but those leaves are facing east and therefore have a low angle of incidence for that time period. And so this trend, you can see in these blue, the shape of this blue is what you would expect for leaves facing east. And in contrast now, the red dot data points show the westward facing leaves, which don't receive as much light, as we'll show here in a minute, but don't face the sun until much later in the afternoon. And so those leaves have pretty different trends in terms of angle of incidence. Now let's look at PAR, or photosynthetically active radiation, as measured on those same leaves. There's that the quantum sensor on the LI-600 as well. And of course, before the sun is up, or when the sun is very low in the sky, very low PAR values on both east and westward facing leaves. But now we see, as expected, the eastward facing leaves receive much higher light than the westward facing leaves during these morning sessions. And I'll make a note here, and this will show up in a couple of slides afterwards as well, that these two measurement periods saw a bunch of clouds roll in. And so these blue data points are lower than expected in terms of PAR because of that cloud cover. And so now the blue data points, the eastward facing leaves, had high light in the morning. These periods were cloudy, and now they're not facing the sun as directly, and so the light's a little bit lower, and then down to 0 in the evening as sunset happens. Again, the opposite is true with the westward facing leaves. Not much light in the morning, but now picking up by about noon, and in the afternoon is when they peak. And the leaves I happen to measure saw much higher light intensity in the afternoon. And so this angle of incidence is kind of another indicator of the directionality that the leaf sees, and it corresponds nicely as expected with light intensity. So now let's look at some physiological parameters and how do they respond. So let's start on the right here. This is my 5PS2 parameter measured from chlorophyll fluorescence. And again, over that same day. And as expected, the east and westward facing leaves in the morning, very early, right at or before sunrise, were very high and about the same. And now at this third session, when we first start to see some difference in light intensity on eastward facing leaves, we do see reduced 5PS2 in the eastward facing leaves, these blue data points, with respect to the westward facing leaves. And that holds throughout the morning when those leaves are receiving more light. So there's more light to drive photochemistry. And we do see a reduction in 5PS2. Again, these were the sort of cloudy periods, which is why these eastward facing leaves kind of have a higher 5PS2 during these sessions, because the clouds were impacting light radiation. But again, in the afternoon is when the westward facing leaves saw much higher light, and again, a much lower 5PS2. So in this graph, I have these black bars that are the mean of the entire data set. So if I did not have a leaf angle measurement, I wouldn't be able to bracket these between west or east facing leaves. These are the values I would see for 5PS2 for those measurement periods. And so being able to kind of analyze your data in some different ways with this additional information might give more insight into differences within canopies or within treatments that would otherwise be kind of hidden without this additional information. So I think this is one of the values of adding leaf angle. It gives you more ways to analyze your data and try and find interesting trends. So this is a very clear story, as I showed in that first experiment, that 5PS2 has strongly influenced by the incident light intensity. And there's really a clear delineation here of light intensity on the leaf that directly impacts very evidently 5PS2. Now on the left graph are, again, the same leaves and looking at stomatal conductance. And there, this is just a singular data set on a single day, and the trends aren't quite as clear. Do see that in the morning time, there's not much difference in the stomatal conductance. By the afternoon, when the westward facing leaves are receiving higher light intensity, there's maybe a little bit higher stomatal conductance in those leaves relative to the eastward facing leaves. Certainly at this time point there was, but the story is not quite as clear. And again, it's a little more challenging with stomatal conductance because that stomatal response is quite slow, and the clouds kind of rolling in and in my experiment may have confounded some of the responses of stomatal conductance. So lastly, on this data set, I just want to show a specific kind of trend that's also useful for this particular measurement period. So the next slide is going to show just this measurement period, or at least data from that measurement period. And so here I want to show the angle of incidence, or alpha, on the x-axis here. And I want to show what photosynthetically active radiation looks like as a function of that. And sort of these points here are kind of the expected response. There's that cosine response of incident light. And again, this is measured by the PAR sensor on the LI-600. And this bulk of my data shows that response quite nicely. But there's a few points here where we have a low angle of incidence. So we're kind of pointing right at the sun, but we still don't have very high light intensity. And I know why that is in this case, and that's because I intentionally measured leaves lower in the canopy that are shaded by leaves above them. So even though these leaves are kind of pointing right at the sun, they're still not receiving full light intensity because they're shaded by leaves above them in the canopy. And sure enough, when I look at 5PS2, which is these red triangles on these leaves that are shaded, see much higher 5PS2 values than kind of the relationship that I would expect as a function of that leaf angle. So again, leaf angle can be combined with PAR data and 5PS2 data to kind of see which leaves in my data set are sun leaves versus shade leaves, for example. And there might be some interesting physiological questions that can be addressed there. But adding the information on the leaf angle kind of helps you tease out maybe to explain why you see different responses between some subsets of your data. So that's a couple of quick examples of how this can be useful. That kind of wraps up the hardware addition section. So again, we have GPS and this accelerometer, magnetometer are the two key updates here that allow for the calculations of leaf angle that will be part of every measurement that is made with the LI-600. So next, I'm going to kind of shift gears a bit and talk about some software updates. So first of all, I think there's two kind of key updates to become familiar with. One is that we've made the workflow a little bit cleaner to reduce the number of button presses and reduce the number of screens that are visible. So in the current released software, version 1, after a measurement is made, and this example is in the auto mode, where the instrument has user-provided stability criteria on when to log a data point. So once a data point is logged, you see the data here, and the screen prompts you to hit the right arrow to go to this next screen, where you now tell it to go to your next leaf. You have the option to either mark that record or complete your measurement session. But just thinking in terms of a workflow of multiple leaves, you would see your data from your first leaf, hit one button press to come to this screen, and then a second button press to start that next measurement. So again, in the auto mode, that's pretty reasonable, two button presses to get to that next measurement. In version 2.0, we've streamlined that. And now, when you log a data point, you again see kind of your log data on your screen. But instead of having to click into that second screen where you leave this screen, now you just simply, if you're ready to make a new measurement, you simply hit the circle button, the main button marked here as new, and that immediately takes you into the ready to make a new measurement screen. And so let's reduce that to just one button press. Again, this is kind of a best case if you add user prompts or a barcode or anything else that will require additional processing. But those have been streamlined as well in the new software. But getting this down to one button press from two can make a pretty big difference. In that diurnal data set that I showed, over the course of that single day, I made about 750 measurements. And so that's 750 button presses removed from my operations for the day, which over the course of many hours of making measurements can really make a big difference. One other thing I'll note is we're now showing you how many data points have been logged in the current session from this main screen. So you can see how many measurements you've made as you go along. The new manual and quick start guide really highlights these changes to the workflow, which we think will make the use of the instrument a little bit cleaner. The other update to the software to briefly talk about is we've added a barcode generator to the PC or Mac application. So when you first open up the application, there's a new window here called the barcode generator, and that's available either with or without an instrument being attached to the computer. So this can be done without an instrument. This section is available. So when you go into the barcode generator section, there's a couple of different options. You can pick what type of barcode to generate. You either choose between a QR code or a code 128. You can either type in this box here, the barcodes you want to generate. You can paste them from a clipboard. So if you've typed them into a notepad or a Word file, you can bring them in that way. Or if you've made a text file, that can be either comma or space delimited, you can import your barcodes from a file. Then once you have the barcodes you wish to generate, once your list is here, I just have a simple list of 4 different barcodes. You would click this generate option, and it takes you here and it shows you here are the 4 barcodes. And this will be a nice printable version that includes the barcode. Here I have selected a code 128 as well as the human readable text associated with it. And then you can either edit them individually, or if you're happy with the barcodes you want, you would click this little print icon, and you can print those either directly to standard paper or A4 paper, and depending on what country you're in. And you can print them to sort of a normal page, or there's at least one option for a printable sticker page. So you can buy this Avery 5163 paper, and it will lay the barcodes out such that there will be one barcode per removable sticker label. So you can print these barcodes directly to those labels, and then put them on your steaks or your pots or wherever your experiment is. So this just helps you more quickly generate these barcodes that you can then scan during your measurements to speed up your measurements. So those are the kind of the big software updates, the improved workflow, and this barcode generator. And that concludes everything I wish to cover. So thank you for your attention, and we're happy to hang around and take any questions that you may have.
All right, thanks, Doug. We did have some questions come in during the presentation. Go ahead and keep sending in any questions you have, and we'll get to them. But some of the questions that we got, one of them was, what's the measurement error for GPS coordinates, and can the GPS be turned off? I think Eric maybe answered that, but somebody else want to jump in and.
Yeah, I can help answer that. So the measurement error for the GPS coordinates is 2.5 meters circular error of probability. So that's kind of a standardized definition of GPS accuracy. So 50% of the time it's going to be within 2.5 meters of the actual location. So that's a pretty good accuracy. And it does depend on your how many satellites the instrument is seeing, and that is shown in your HDOP value, how good the signal strength is. And then the GPS signal can be, or the GPS feature can be turned on and off in the software. So you do have that ability as well.
Okay. Another question. Is fluorescence data taken after or before stomatal conductance data? And that might have been.
I can go ahead and answer. I can answer that. That's fine. Sure. So the steady state fluorescence measurement is made simultaneously with the stomatal conductance data, or along with while the cuvette is stabilizing. And then as soon as the either log button is pressed or the stability criteria is reached, the stomatal conductance data is logged, and that is when the saturating flash is given to complete the fluorescence measurement. So it's done during, and then the flash is immediately following the conductance data.
Another one for you, Doug. Does the solar parameters from the GPS, is it corrected by time zone, including changes on daylight savings time?
Right, so the GPS clock is in UTC time, and that's what's used for all of the leaf angle calculations. So it's all done on sort of that system. And so that's the time and date stamp in the GPS section will reflect that. There is a second local time available in your data sets in the system group. And there's a section in the software where the user can indicate their UTC offset and adjust that local time.
Jason, this was a question you had answered, but is there an algorithm to compensate for leaf angle differences?
I mean, the short answer is no, because there's not really anything to compensate for. I mean, as Doug showed, it's a pretty interesting thing on its own because it controls sort of availability of light to the leaf in a lot of ways. And then that has direct controls on sort of the biological behavior you see, either the conductance or 5PS2 and the data that Doug showed. So for most people, that would be interesting on its own. And so that's why they would record leaf angle. If it's not, and you're trying to get at something, you know, where you maybe have one measurement that's more representative of the mean of the plant or some defined state, then you'd control for leaf angle in your sampling scheme. You pick leaves that are all at the same angle, oriented the same direction towards the sun, probably at the same nodal position, at the same stage of development. And that would just be part of your sampling strategy to sort of constrain your data that way. To go back and do it after the fact, you're talking about like a multi-dimensional sort of canopy scale model. And that's not simple. So, yeah.
Okay. We did get a question on if there was a hardware upgrade for older 600s to add the GPS and accelerometer, and we do not have a hardware upgrade available. However, the software updates that Doug just talked about, the barcode generator, you can update your existing 600 to start using those new features, but we don't have a hardware upgrade for existing 600s. Some other questions. I know people asked, is the recording of the webinar going to be available? Yes, we are recording today's session, and we will be sending out a link to that recording here in the next couple of days. So everybody that registered, even those that weren't able to join us live today, we'll be sending an email out to all of you so you can access the webinar at a later date. And keep sending questions in. We've got time, we can keep answering them. But another thing I wanted to let you all know about, on June 15th, we're actually planning on doing another webinar, and I believe Jason's the presenter for that. So it'll be on the new 600 features that Doug just talked about and how you can use the 600 to complement measurements with our LI-6800. Stay tuned. We'll probably get an email out with registration link here in the coming weeks, but I did want to let you know that that's the next topic that we're going to cover related to the Porometer, Fluorometer, and photosynthesis system. So
I see one more question, Abby. There's two more now, but one is asking about specific satellites in our satellite groups and what our GPS transceiver receives. And I don't remember which systems this specific part receives. So I'll have to get that information to that person later, unless somebody here, Jason or Eric, knows off the top of their head, but I don't recall. So we'll get you that information.
Okay. Let's see. My question. Any other questions that came in? Is there a narrow leaf chamber attachment for the 600 like there is for the 6400?
And the answer to that is currently there is not. Currently there is only the standard aperture available.
But we're always looking into new things, so we'll just have to see. Okay, go. All right, well, I think that answers the questions that have come through. We will go ahead though and stay online here for a little bit. So if you do have more questions, go ahead and type them in and we can type them back to you. But for everybody else, thank you so much for joining us, and watch your email for a link to the recording. Thank you.